Okay, these are our notes for calculating force. Okay, so for force, we can use our formula triangle. So our main formula for force is force equals our mass times our acceleration. Now when we do this, our force should be in newtons. Newtons is kilograms times meters per second squared. So that's the breakdown of those units. Our mass should be in kilograms, and our acceleration should be in meters per second squared. Okay, so when we are doing our formulas, so sometimes when it asks for force, force is going to be equal our mass times our acceleration. Sometimes it might ask us to find the mass. So we can use our formula triangle. If I just put my finger over my mass part, what I'm left is my force on top of my acceleration. So when I'm calculating for mass, it equals my force divided by my acceleration. Sometimes I might be asked for what's the acceleration. And so if I cover up the acceleration, I have my force divided by my mass. And so acceleration equals my force divided by my mass. So these are the formulas that we would use when solving force problems. So I'm just going to run through the first one with you. So we still need to do all 5 of our steps. So our first step is to underline the question. So a baseball with a mass of 0.8 kilograms is given an acceleration of 20 meters per second squared. How much force was applied to the ball? So that's my question. How much force was applied? So I'm looking for force. Then I need to write down my variables. I don't know what my force is. I have a mass of 0.8 kilograms. I have an acceleration of 20 meters per second squared. And so those are my variables. My next step, I write down my formula. Force equals mass times acceleration. Then I put my variables into my formula. So my force equals my 0.8 kilograms times my 20 meters per second squared. Then I'm going to put that into my calculator. I end up getting 16 newtons. Okay? So then once I get that, I need to check for sig fig. So this has 1 sig fig, this has 1 sig fig, so I need to round that to 1 sig fig. And so I would get 20 newtons when I round that. So that's how I do that problem. We've been running through a lot of these problems, so you should be able to handle this worksheet. There's a couple things that I wanted to go over with you to give you a little bit of help. So this first one, or for number 5, you need to find, it asks what is the, this is a 2-part question. So for part A, what is the acceleration? And it gives you this formula for acceleration. This velocity, that's the same thing as when we did speed final and speed initial. Okay, so when you do this, you're going to find acceleration up here. And then for part B, you're going to be finding the force. So you're going to use the acceleration in your answer here. And then you also have the mass up here. That's that information you'll use for part B. And then finally, this last one, number 6, this is a tricky one. So this is, again, a 2-part one. You're going to first have to, the question is, what is the mass of the bus? And so the first thing you're going to have to do is you're going to have to figure out acceleration. So we don't know what acceleration is, so you're going to have to use this formula to find acceleration. Once you find that acceleration, then you can use your formula, mass equals force, whoops, this should be force. Mass equals force over acceleration. So first, for this one, you're going to find acceleration. Second, you're going to use that acceleration in this equation to figure out the mass of the bus. That should be enough information to get you going. Just a reminder to do all 5 of those steps. Underline the question, write your variables, write your formula without the numbers, put your numbers in, put in a calculator, round to sig figs. So for all of these, okay? And when you're done, double check it over and turn it in.